Jeff deposits 10 in a fund today and 20, 15 years later. Interest for the first 10 years is nominal discount rate of D compounded quarterly, and thereafter nominal interest rate 6% compounded semi-annually. Accumulated balance at the end of 30 years is 100, calculate D. So first thing to note is that here they are using the symbol D for the more common notation D superscript 4, because this is nominal discount rate D compounded quarterly. So the usual symbol for this is D superscript 4, but here they have decided to use D for it. So we keep that in mind. And now we know that under a discount rate, in T years, a principal would grow to P 1 minus T superscript M by M power negative MT. And in this case, M is equal to 4 for the discount rate because it's compounded quarterly, 4 times a year. In the first 10 years, this deposit of 10, so there are two deposits, one is 10 and the other is 20. So we take care of them separately because they're happening at different times. So the deposit 10 happens today and it sits for the full 30 years because we are interested in the accumulated balance at the end of 30 years. So in the first 10 years, it encounters the discount rate over here, compounded quarterly. So it will grow to 10 times 1 minus D over 4, because M is equal to 4, power negative 4 times 10. And then in the next 20 years, it encounters semi-annual interest rate. So this is what it has grown to in the first 10 years. And so we take this quantity and grow it for another 20 years under a semi-annual interest rate of 6%. So that means this balance will be multiplied by 1 plus 0.06 by 2 power 2 times 20, because remember, we have a similar expression. Under in the interest rate, it grows to 1 plus I superscript M by M power MT, and M is 2 for semi-annual compounding. And we are considering 20 years of semi-annual compounding. So I multiply the 10 with this quantity to get 32.62, and I have this one also, 1 minus T by 4 power negative 40. This will be the growth of the first deposit of 10. And then the second deposit of 20 happens at time 15. And since our final destination is time 30, so it means that this second deposit has 15 years to stay, to grow. So in 15 years, this deposit of 20 grows to 20 times 1 plus 0.06 by 2, power 2 times 15, because this deposit will only encounter the semi-annual interest rate. Remember, the first 10 years were under the quarterly discount rate, but this one is happening at 15 years, so this will not encounter the discount. This will happen what was happening in the next 20 years, which was semi-annual compounding interest. And since this one stays for 15 of those 20 years, so that's why we have this expression, and this equals 48.55. So we have seen what happens to the initial deposit of 10, that's what it grows to in 30 years. And then the second deposit of 20 grows to 48.55 when time is 30. And the sum of these two is the total balance, and we are given that the total balance is 100. So we have this equation. We first subtract 48.55 from both sides, and we divide by 32.62, and then you take the negative 40th root of both sides. So we end up with 1 minus T over 4 equals 0.9887. And then when you do further algebraic manipulation, and you move D over 4 to the right side, subtract the 0.9887 on the left, and then multiply by 4. So we end up with D equals 0.0453, which is 4.53%, and that's choice C.